Survival analysis is a type of modeling technique which is used to model time to an event. Of time to an event is time to death after heart attack, time to loan payment, time to get a job after graduation. We often need to model for the time to happening of an event. To build such a model, we use survival analysis. Question arises, why can't we use the linear regression? There are basically three reasons. The distributed outcome, time to an event, is usually not normally distributed. The second thing is censoring. Censoring is nothing but a partial information. So time to event data, sometimes some of the observations are not fully observed, in the sense that sometimes we do not have full information about a particular outcome. We cannot take such an observation in linear regression analysis. We can take it in survival models. That's a special feature of. So do not have an independent set of variables or explanatory variables. We cannot use linear regression. But if you only have time to an event, only we have the duration. That is all we have. Whether it's heart attack or whether it's getting a job, we can model for the time to event using survival model in such a scenario, even without having explanatory variable. We cannot of course do that using linear regression. So that's the basic difference or the main difference between the survival analysis and the regression based models. First thing is there should be clear definition of an event. What an event, what is death, what is default, what is getting a job. There should be clear cut definition of that. Should not be any confusion at all. Time scale, are we measuring in terms of the month or year or days? So that is very important. That should be clearly defined. Again, origin of the event, like when it starts. Time to event is considered to be a random variable which can take any value from 0 to plus infinity. It can take any value between that, and we are interested to know what is the time to variable. How do we know actually for a particular event? For that we need a population data. Individuals in our population do not enter the study at the same time. When the study ends, some individuals still haven't had the event yet. For example, if you are doing a study on a patient who is undergone a heart surgery, is that person dying after he has undergone the heart surgery, and the time window that you have taken for study is 5 years. If an individual is not dying in that 5 year, well, that can be considered as a censored event, because after that 5 year, 5th year, we don't know what is going to happen with that individual, whether it's death, whether it's getting a job or defaulting on an account, hasn't really happened by the end of the study. Okay, it has happened after that, and we don't know when it is happening, but still we can include this observation in the data set. Some individuals, they drop out of the study in the middle of the study, and we have no clue what exactly is happening to these individuals. Starting point here, so that is the starting of the study, and then you have an end period of the study. So I am observing the event from the start to the end. That is my study window. There are 4 people in my population. Of course there will be so many of them, but for example sake, let's say there are 4 individuals I am studying. The first individual starts from the very beginning, and then it reaches up to the end, and this event hasn't happened yet. Okay, let's assume that the event is death. That means the individual is still alive. We don't know when he's going to be dying. So we do not have information on the event for that individual, for individual 1. For individual 2, it starts at the beginning and it's drop off in the middle of the study. It doesn't continue. We don't know what is happening with this individual. So first individual, second individual, both are censored events. The third individual here is the one which is a staggered entry, or it entered the study not at the beginning. It enters the study in the middle of the study, or is somewhere in the middle. Okay, and then the event happened before the end. Okay, so that's not a censored event. And then the fourth individual, again a staggered entry, doesn't start or doesn't enter the study from the very beginning, but by the time it is ending, or the study period is ending, we have had the event happening for that individual. Okay, so why it is happening and why it's not happening, well, that is not something important for us. The only thing that is important for us is that when exactly is the event happening. Okay, what is the time, exact time? That is the most important thing in the survival mode. An event defined is survival function, denoted as S of t, so which is probability that an event happens, or the event happens after time t. Okay, capital T is when the event happens, small t is the time that I am taking into consideration. Is this hazard function. It's the instantaneous event rate, otherwise known as the force of mortality. We define it as given that a patient has survived till time t, what is the probability that it's going to die at time t. So it's the conditional probability. Okay, using the same example we can define hazard function. The information till we estimate these functions, actually we estimate only the survival function, we can get the probability density function and the hazard function directly from the survival function. So we only care about the survival function. We estimate the survival function in survival analysis using a particular type of estimation known as Kaplan Meier estimation. To understand it better, let me give you an example. There are 50 patients. In the time 1 person died. So what's the probability that somebody is going to survive beyond time 1? It is 49 by 50. If you know the basic rules of probability, it's the number of surviving by total number of population. Okay, so 49 by 50 is the probability that you are going to survive beyond time 1. Hence, the conditional probability that you are going to survive beyond time 1 is 49 by 50. I'll denote it as P of 1. People enters the population or enters the study at time 2. Out of 49, 2 people die in time 2. So what's the probability, conditional probability, that you are going to survive beyond time 2? 47 by 49. But survival function or survival probability is actually the unconditional probability, not the conditional probability. How do we get unconditional probability of surviving beyond time t? First of all, we denote it as S of 2. Okay, so S of 2 is nothing but product of conditional probability of survival at time 1 multiplied by the conditional probability up to time n. Just to generalize it, your survival estimate is nothing but is the product of your ni, total number of population entering at time t, minus number of people dying or number of events happening, which is denoted as ti, by total number of population at time t. You can see 500 people enter the population, then no event happens, survival probability is 1. Okay, because 500 by 500 is equal to 1. Okay, and then 8 people. Okay, survival probability gets decreased to 0.98. I can see on the screen, and then it keeps on going down. Ideally, if you continue doing that for infinite period of time, it should go down to 0. But then we have a limitation. We have a limited study period. Well, curve looks like this. As I said, it starts with 1, because at time 0 nobody will die, right? Because it's just the starting of the study period. So all the people in the population are now surviving. So the probability that you are going to survive beyond this time 0 is 100%. Okay, so that's probability of 1. And then slowly as people die with time, the survival probability decreases with time. In particular case, in the we have ended up at 0.4 probability. Okay, but if you continue doing that for infinite period of time, it will be 0. So you can always plot the confidence level around the survival curve. There are several applications of survival analysis. It's very much used in the healthcare industry. The event of interest in healthcare industry is the whether a patient is dying or is surviving. It's very important to know that how many patients are going to survive beyond the first year, beyond the second year, third year of the operation or the treatment that has been given to the patient. It's very well known in insurance industry as well, because for pricing purposes, the insurance provider need to know that how many people are going to die. uh, what's the probability that n number of or x number of people are going to die in the first year, in the second year, and so on. And based on that, it charges, or it sets the price of different insurance product. Very well known in credit risk analytics as well. In the banking domain, there are so many events that happen related to lending. A customer can default. Yeah, the customer can go into delinquency or bank. The industry need to know that when is that event going to happen, or what's the probability that an event will happen next year, at 2 years from now, 5 years from now, and what is the probability that a particular customer or particular set of customer are going to default is used mostly. Thanks.